Welcome, my friends, to the very first lecture of our amazing journey to the ISTQB Test Automation Engineer Certificate. I hope you're excited as me because we're diving into the latest version of this certificate, V2. Now, you might easily anticipate that ISTQB has designed this version to keep up with the evolving universe of test automation, and you'd be 100% correct. V2 is not just a certificate, it's about staying relevant in today's fast paced tech industry. So, without further ado, let's roll. Alright, folks, let's start by talking about what makes test automation, well, test automation. You see, there are certain conditions that have to be met, and if they aren't, we are probably dealing with something else like manual testing. Now, when we think about software testing, there are a lot of activities going on, but the big stars of our automation show are test execution and test reporting. And for us to call it automation, these activities need to have some very specific criteria. It's kind of like saying, if it doesn't have cheese, it's not a pizza. So, what are these must have features? First, it has to be automated, like fully automated. No human intervention is allowed during the execution or reporting processes. So, if you are clicking buttons manually, we can't call it automation. Next, it has to be performed using tools. And no, I don't mean a wrench or a hammer. I'm talking about software tools that are purpose-built to run the test for us. Think Selenium or Appium as well-known examples. And finally, auto-assertion. This is where the tool compares what really happened, also known as actual results, with what should have happened, aka expected results. So, long story short, if it's automated, uses tools, and can call out differences between actual and expected results, boom, we're talking test automation. Now, let's move on to a term you've probably heard a million times, SUT, or System Under Test. I bet you remember this one from the foundation level, but basically, System Under Test is whatever you are testing. It could be a tiny piece of code, an entire user interface, or even a massive API. Of course, test automation doesn't exist in a vacuum. It has to interact with the system under test to actually evaluate it. So let's take a look at few ways this interaction can happen. First up, with no UI involved. I believe unit testing is a good example here as tests are performed with no user interface available. Second, UI-based interactions. For instance, let's say you want to test the checkout process on an e-commerce app while applying a discount coupon. The automation tool will navigate the UI just like a human would, clicking buttons, entering the text of the coupon, and finally verifying the discount price is applied. Sounds cool, right? Then we've got protocols. An example could be automatically testing an FTP server to make sure files are transferring successfully. And lastly, we have connections. This is often seen in automated system integration or automated database testing, where the automation tool evaluates the proper connection between our systems or between our system and the storage solution. Alright, let's now dive into what makes test automation awesome. First off, test automation is way faster than us humans. Machines execute tests at lightning speeds, and as a bonus, they generate reports just as quickly. Now, because tests run so much faster, you're saving a lot of resources in the form of time, effort, and money. You don't have to pay a team of testers to run the same boring test case 50 times. Instead, your automation tool handles testing while your team focuses on more important tasks, like exploratory testing and coming up with innovative test techniques, or more importantly, deciding where to order lunch. Also, you can run way more tests for every build. This means quicker time to market and finding more defects. Hence, the overall quality of the work product will definitely improve. Now, one of the major pluses of test automation is that it can handle tests that are flat out impossible for humans. For instance, parallel testing, where web tests are performed in parallel on different browsers at the same time, remote testing, where tests are performed on remote servers, and performance testing, where you're trying to simulate 1,000 users clicking on your app at the same time. Good luck doing that manually. Automation is also incredibly precise. It doesn't get bored, tired, distracted, or accidentally type TEH instead of THE. This precision brings two major benefits. First, automation is far less error prone, which is especially important for complex tests like full system regression testing. So imagine manually testing an entire system every time there is a minor code change. Mistakes would be inevitable here. The second is that automation improves consistency. Imagine a bored software tester skipping test steps or a new team member doing things differently. This inconsistency is totally eliminated with test automation. Lastly, test automation can actually help improve your system reliability. So, in the context of software development and testing, the term reliability refers to better availability and recoverability. And let me break this down for you. Availability means how often your system is up and running in its optimal conditions. So, because test automation can catch and fix bugs that might cause downtimes, it can make your system available more often. Recoverability, on the other hand, refers to how fast your system bounces back after a failure. Automation can help simulate failures and verify that recovery measures are working properly. Of course, test automation isn't all sunshine and rainbows. It does have its drawbacks, so let's explore some of them. First up, the cost of getting started. Test automation needs a solid investment upfront. But once you're set up, it pays off big time in the long run, as mentioned before. You'll need skilled test automation engineers, also known as TAEs, and test automation tools aren't always cheap. Add to that the cost of training your team on how to use these tools effectively. Also, don't forget the time and effort needed to implement your test automation solution or task, and the time and effort required to write all those test scripts. Furthermore, and that's a big one, test rigidity. Automated tests are, well, stubborn as a mule. Once you write a test script, it doesn't adapt easily to changes. For example, if you want to follow a newer testing approach, it usually means you need to update your existing scripts, which is not an easy task. Similarly, when your system under test evolves, like updating the system's UI, You will often have to re-script your automated tests, a bit of hassle, but it comes with the territory. One more thing, successful test automation requires crystal clear objectives and planning, and I think this one is pretty much self-explanatory. And finally, test automation itself can introduce its own problems. For instance, flow test scripts, which are scripts that are poorly written, might report false positives, I mean saying everything is fine when it's not, or false negatives, screaming bug when there is no issue. Another source of trouble is dependencies. Sometimes automation engineers depend on poorly configured test libraries, which can lead to inaccurate results, of course. And finally, breaking the system, where our scripts might send incorrect commands to the system under test, causing crashes. So, understanding these drawbacks help you work around them, and trust me, when done right, test automation is worth the effort. Alright, I believe we've reached the final section of this lecture where we will look at the limitations of test automation, simply things it cannot do. As a starter, automation can only do what it's told. If it's not in the script, it's not happening. There's no room for creativity or those brilliant moments you get with exploratory testing. For example, if your automated test is checking if the login works, it's not going to suddenly think, what will happen if I try entering emojis instead of passwords? Nope. It will just stick to the script and move on. Secondly, some tests are just not meant for automation. You see, the human touch is sometimes unreplaceable. Let's say you are checking if the website design is user-friendly or if a particular font gives off a trustworthy vibe. That's purely a human job. Similarly, accessibility testing is not so much automation friendly. Also, some tests don't have results that machine can understand. For instance, imagine you're testing a smart IoT device, but it doesn't have an API or even logs to tell you what's going on. It's like asking a toaster to explain why it burned your toast. It just can't communicate back. So, without an observable interface, automation is out of luck. Also, some results may not be interpretable by the test oracle. If you're wondering, a test oracle is a mechanism that tells you if the test has passed or failed. So sometimes the oracle can't do its job. For example, testing machine learning models is very tricky and test results are too fuzzy for automation to handle without extra human help. So, test automation is great, but it's not magic. It has its limits, and that's okay. Very well. I believe we have done with this lecture, and what a good start for our journey. It's very important to keep on track and learn things step by step before moving on to the next topic. Therefore, if you feel like you need any further explanation, don't hesitate to post in the QA section and I will make sure to answer your inquiries as soon as possible. Take care and I'll see you on the next one.